Okay, good afternoon, class. So at this point we're looking at the November 2018 paper, correct? Alright, so at this point you guys have answered the first 50 marks, the first 3 questions. So this is grade 11, paper 1, November 2018 from our school. No? Alright, so let's go with the first question. So the first question we are told, question 1. Point one. So half x corrected to 2 decimal places. So if it says to 2 decimal places, I know we're going to use the quadratic formula. Okay. So the quadratic formula is x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. Okay. Alright, so your A value is 7, B is 3 and C is minus 2. So minus 3 plus minus the square root of 3 squared minus 4AC over 2A. Okay, so that gives us, you've got 7, you've got 3 and negative 2. So it give you negative 3 plus the square root of 65 over 40. In decimal is 0.61. 0.36, sorry. No, there's a 37. No, 36. Okay. Or the other one, which is negative 0.7. Okay. Now, this is the point at which you must show your substitution into your quadratic formula. Okay. If you don't show this step and you go straight into the answer, you're going to lose 2 marks. Okay. So watch out for this question here. Okay. And for those of you using the silver calculator, make sure you're showing the substitution in as well. Okay. Otherwise, you will lose that mark. In 1.1.2. we got x plus 5 is equal to the square root of 3 minus 3x. People, is the root isolated already? Is the square root isolated already? The answer is yes. So I can go and square both sides. Not so. So that's going to give us x squared plus 10x plus 25. Now if you didn't get that answer, you must always write out the binomial twice and you multiply it. Don't keep yourself brave and work it out if you are getting it wrong now. Okay. So that cancels that thing. So that gives us 3 minus 3x. So we get x squared, we bring everything to the left hand side. 11x plus 3x is going to give you 13x. 25 minus 3 is 22. Okay, so that's going to give you 11 and 2. So x and x, 11 and 2, plus. Again, if you can't factorize a trinomial, use the quadratic formula. So I know that is one thing that you guys get right all the time. Okay. So x is equal to negative 11 or x is equal to negative 2. So what I do is I need to check if it works. Okay. So what I do is I substitute it into the original function. Okay, in the original equation. So I put negative 11 in here, it's going to be negative 11 plus 5. It's negative 6. If I put negative 11 in here, it's going to give you 33 plus 3 is 36. The square root of 36 is 6. Is 6 the same as 36, negative 6? No. So negative 11 is not a solution. Okay. Then we got the same with negative 2. Negative 2. And if negative 2 plus 5 is 3, and 3 times negative 2 is positive 9, the square root of positive 9 is 3, so that solution works. Okay? Let's look at the next question. The next question is 1.1.3. Here we got x squared has to be greater than or equal to 3 into x plus 6. So first multiply it out, get it into standard form. So x squared must be greater or equal to 3x plus 18. Bring everything to one side, so x squared minus 3x minus 18 is equal, it must be greater than or equal to 0. So that factorizes into 6 and 3. The 6 is negative, the 3 is positive. So this is what we get, critical values. We don't say x is equal to 6 and minus 3, we say x is, the critical values is 0 and minus 3. Now if you use the quadratic formula here, you go straight into critical value. You don't have to show the factors there. Did you see that? So what I do is I say, okay, since that parabola is positive, the graph is smiling, there's the minimum value. Now minus 3 and 6 there. So it says that the function must be more than 0. So is that above or below the line? It's above. So more than 0 it is where it is positive. So is that part there? Is that continuous or breaking solution? The solution is part, so it's broken. Not so. In other words, we say x is less than minus 3 or equal, or x is greater than or equal to 6. Okay. The next question is simultaneous equations. To solve for x and y simultaneously, and it's worth 7 marks. 6. Okay. So what we're going to do is we're going to first sort this one out here. So we know that 27 can be written as 3 cubed raised to the x over 3 is equal to 3 to the y minus 1. I need to make the bases the same for the exponents to be equal. So 3 times x over 3 is going to give you x is equal to 3 y minus 1. You see the bases are the same. Therefore x is equal to y minus 1, and that's equation 1. And there's equation 2. So wherever I see an x, I replace it with y minus 1. So we're going to substitute equation 1 into equation 2. So as you can see there, y minus x will be replaced there. Okay. So that will simply give us 2 into y minus 1 squared minus y is equal to 5. Sort out that binomial square, it's 2 into y squared minus 2y plus 1 minus y is equal to 5. Again, if you can't do the binomial square, write it out twice. Okay. Multiply that in, that's going to give you 2y squared minus 4y plus 2 minus y is equal to 5. Bring it to one side. The 2y squared minus 5y minus 3 is equal to 0. Again, you can use a quadratic formula here since it's a quadratic equation. So that's going to give you negative 6 plus. So y is equal to negative half, or y is equal to 3. Whatever solve the x? No. So what do? I substitute that back into there. So I now say x is equal to, if y is negative half, so it will be negative half minus 1, which is negative 3 over 2. Or, this is normally under here, ne? Or, x is equal to 3 minus 1, which is 2. Okay? Next. Now using a calculator, simplify the following. So 50, we know the biggest perfect square that goes into 50 is 25 times 2. The biggest square, perfect square that goes into 8 is 4 times 2. So 4 times 2 is 8. And there's going to be 7 root 2. The square root of 25 is 5. So it's 5 root 2 plus the square root of 4 is 2 root 2 over 7 root 2. So 5 root 2 plus 2 root 2 is 7 root 2 over 7 root 2, which is equal to, okay. At times we know when you guys are using calculator, if we know that you're using calculator, you get 0, okay. If 5 to the minus x equal to 10, simplify. So what we do is we move from the known to the unknown. Now that 5 to the minus x equal to 10, that's the unknown term. Okay, so what we do is, we first work with what we're familiar with. So this here is your exponential expression with a plus between. So what do? We need to break up and factorize. Not so that will be 2 to the x times 2 to the minus 1 plus 2 to the x times 2 to the 1. Break 10 up into product, so it's 5 factors. So it's 5 times 5 to the 5 times 2, which is going to give you 10 to the x. This is going to give you 5 to the x and 2 to the x. 5 to the x times 2 to the x. Okay. So what you should note now is that 2 to the x is a common factor. Can you see that? So you got 2 to the x. What we left with? 2 to the minus 1 plus 2 to the 1 over 5 times 5 to the x times 2 to the x. So that cancels. Then what are we left with? Results 2. Okay, so now you see 5 to the x in the denominator. I'm going to leave it there for now. So what I'm going to do is I'm going to sort out my numbers here. Okay, so that I put in the calculator, there's going to be 2.5, so it's going to be half. No? Let's check. So it's going to be 2. Get 2 to the exponent negative 1 plus 2 over 5. It's half, as I said. So this in the black bubble is going to be a half. Now you see that 5 to the x is in the denominator. If I bring it up, what would it become? 5 to the minus x. Can you see that? And what did we say? What is 5 to the minus x? Equal to 10. Can you see that, people? So what can I say? It's going to be half times 10. And what's half times 10? 5. Okay. This is a good one. This is number 1.4. 1.4, we are given that a is equal to 11 plus 3x squared minus 6. What type of expression is that? That's going to be a quadratic. Not so. It's going to be a quadratic expression for the area or something. By completing the square, they will determine by completing the square the minimum value of a. So what we do is we say, okay, we write it first in the form of ax squared plus bx plus c. Okay? Which means to say it's going to be 3x squared minus 6x plus 11. Okay? Then we say, okay, must factorize the 3, so it's going to be 3 into x squared minus 2x plus 11 over 3. Okay? So what must we do? We must add the number here to complete the square with, and must subtract the same number. And what's the number in this case? It's going to be b times a half, which is negative 2 times half, which is 1, and we square it, it gives you 1. That is my perfect square trinomial. So it's 3 into x minus 1 squared plus 8 over 3. Is that correct? Check if that's correct. Yes, okay. So what do I do now? Multiply the outer bracket, get rid of the outer bracket, so it's going to be 3 into x minus 1 squared plus 8. So as you can see, this is a quadratic pattern, or a quadratic expression. It means to say the graph is smiling, which will give you a minimum value. If the graph is frowning, or it's a negative, it will have a maximum value. Not so. A turning point at the maximum. The question says, by completing the square, determine the minimum value. Therefore, as a minimum, A has a minimum value of 8. And it will occur at x is equal to 1. But he didn't ask with reference to which value of x would be a minimum. Okay? You guys understand? Right. Carry on with our lives. Question 2. Nature of roots, our favorite in paper 1. No? Favorite to leave out. Shouldn't be, no? Not that complex. Discuss the nature of the roots of the following quadratic equation: ax squared plus bx plus c equals 0 if the following condition are given. A is negative, B is positive, and C is 0. So the nature of roots is dependent on what? It's dependent on delta, which is b squared minus 4ac. If delta is greater than 0 and a perfect square, the roots are real, rational, and unequal. If delta is greater than 0 and a non-perfect square, the roots are real, irrational, which means to say it's a circle, or radical, and unequal. If delta is equal to 0, the roots are real, rational, and equal. If delta is negative or less than 0, the roots are non-real. Those things are supposed to have been deeply embedded in your head. No? So we are told that B is greater than 0, which means to say B is positive. Not some positive square, minus 4. My A value is negative, but my C value is 0. Anything times 0 is 0. So what does that mean to say? Your delta is actually a perfect square. Can you see what is left? Your B, the coefficient of x, which is B, and is being squared. Can you see that, people? So what can we say about the nature of this root? Roots is going to be real. It will be rational or irrational? Rational, because that's perfect squares. And unequal. Okay? Let's look at the next question, 2.1.2. Again, delta is equal to b squared minus 4ac. We are told that, okay, b squared minus 4, what is ac equal to? B squared. Can you see that? Which means to say, here we're going to get negative 3b squared. What do you notice now? Whatever b is, it will be positive, not so? Because it's being squared. And a positive number times a negative number will always be negative. Did you see that? So what can we say about the nature of this roots? The roots are going to be, therefore, the nature of the roots is going to be, roots will be non-reals. Okay, we're imaginary. Okay. You go to the next, first year at university and you do maths. It's a whole week you spend on unreal roots. Roots that doesn't exist. Imaginary numbers. Why? To widen your imagination. No?
How do you know they exist?
Sorry? How do you know?
They don't exist. Yeah.
Say again?
How do you know they exist? They don't exist if you imagine
How do you know they don't exist?
yes,
They imaginary because what is the square root of negative 4? Put in the calculator, you're going to get an error. Most. So that, to us that's non-real. It doesn't exist. But at university you go further and you say, okay, now you're going to have an imaginary axis also. Okay. So you normally when we got the Cartesian plane x and y, they call that the organ plane. Okay, where you have imaginary roots and stuff like that. Okay. Very exciting. Right, 2.2. For which values of m will the equation 2x into x plus 1, close brackets, plus m equal x have non-real roots. Non-real roots means what? Delta must be negative, not so. So, we must first get it in the form of ax squared plus bx plus c. So let's multiply this in. What do we get? 2x squared plus 2x plus m equals x. We bring that over, becomes 2x squared plus 2x minus x is going to give you positive x plus m is equal to 0. Not so? So we said that we need to work out delta, which is b squared minus 4ac. Nature of roots depend on delta. What's your b value here? 1. So it's 1 squared minus 4. Your a value is 2. And your c value is m. So this simplifies into 1 minus 8m. So we said for non-real roots, what do we know what's going to be for non-real roots? We said delta must be less than 0, which means to say negative. So in other words, delta is 1 minus 8m. So 1 minus 8m must be less than 0. So negative 8m has to be less than negative 1. How do I get m on its own? Divide by negative 8 both sides. What's going to happen if you divide an inequality by a negative? Swap around. Okay? Any confusion there? Then in 2.3 we are told that if f of x is equal to the root of 2 minus x over 5 minus x squared, for which values of x will this f of x be undefined? When will something be undefined? The denominator is equal to 0. So what is the denominator here? 5 minus x squared. That is equal to 0, the sum will be undefined. So you take x squared over the equal sign, become x squared is equal to 5. You get x squared on its own, or x on its own, I square root both sides. So if I introduce square root, what must I not forget? Plus minus. So x is equal to plus minus the square root of. Okay. I asked you to do question 3 as well. In question 3, we are told, given the linear pattern. So linear, what is exclusive to linear patterns? What would you find in linear patterns only? First common difference, not so. What would you find in a geometry? You will have a common ratio. Okay, and then quadratic is you will have a second common difference. Alright, so yeah, we're actually adding 5. Not so to get from one term to the next term. So since it's linear, it's going to follow a pattern Tn is equal to a plus n minus 1d. Okay, which then gives us your a value is 12 plus n minus 1 times 5, which is 5n. 12 minus 5 is 7. So Tn is equal to 7. Tn is equal to 5n plus 7. There's one way of doing it, or you can do it by using the other formula, which is Tn is equal to Pn plus Q. Where P is your common difference, so it's going to be T1 is going to be 5 times 1, which is your term 1, plus what is going to give you 12. 5 plus what is 12 is 7. You test for T2, so it's going to be 5 times 2 plus 7 is 17, yes. T3 is going to be 5 times 3, which is 15, plus 7 is 22. So Tn is going to be 5n plus 7. You can do it any of the two methods. You're going to get the full mark either way. Okay? Then in 3.2, the question says, 3.1.2, question says, calculate the value of the 11th term 11. So 312. So T11. So wherever I see n, I put a 11. So 5 times 11 plus 7. So it's going to give you 55. It's going to give you 62. So is T11 62? Yes. Okay. The next question. It says how many terms are there in this pattern? So if you look at the pattern, the nth term or the last term of this pattern is 172. Not so? So this pattern carries on and it ends off at 172 then. So we say, okay, so 3.1.3. So Tn is equal to 172. But what is Tn? 5n plus 7 is equal to 172. They get over the equal sign. So 5n is equal to 172 minus 7 is 165. Divided by 5 both sides. So therefore n is equal to the 30. So therefore there are 33 terms in the pattern. You guys understand in the sequence? So if you extend this pattern, you go 12, 17, 20, 20. Carry on. The 33rd term will be equal to 172. Okay? With 3.2, we are told that given the first 4 terms of a linear pattern. What is linear? Mean to say, what is exclusive to linear patterns? First common difference. Okay, so if you work out your first common difference for 3, x and y and 30, what would that difference be? X minus 3, and that y minus x, and that 30 minus 1. But since it's linear, that will be equal, not so. So you go x minus 3 is equal to y minus x. So y is the subject of the formula, is equal to 2x minus 3. That's the equation. Okay. On the other hand, we got y minus x is equal to 30 minus 1. Take that over, becomes 2y minus x is equal to 30. In this equation, 2. I needed to make in one of the 2 equations x or y as the subject of the formula. Not so? Since I already made y the subject of the formula in 1, I don't have to do it in equation 2. Okay. So now we're going to substitute equation 1 into equation 2. Okay, so if I see a y, I replace it with 2x minus 3. So that's simply going to read 2 into 2x minus 3 minus x is equal to 30. So 4x minus 6 minus x is equal to 30. So 3x is equal to 36. So that means you say x is equal to 12. Not so? But you must calculate the y value as well, no? They say y is equal to, I'm substituting into equation 1. 2 times 12, which is 24 minus 3. Y is equal to? You all agree with that? Huh? Yes, okay. 3.3. In 3.3 we are given the quadratic pattern. Okay, so now we are given a quadratic pattern. Yes? Okay, we've got the quadratic pattern. They ask you to write down the next term in this pattern. So how do I move from one to the next? 193 minus 244. Gives us negative 51. 148 minus 193. Negative 45.